Microscopy. I think. Oh. You need to know, there's two key things you need to know about microscopy. The first one is the history and electron microscopes and how they're different. And the second one is the magnification equation. So we'll look at the electron microscope to start off with. Originally, we use light microscopes. Well, that's what you use in class as well, because quite frankly, schools can't afford an electron microscope. They're a little bit expensive. And you use lenses and light. And that was developed sort of the 1700s-ish. Some were early ones were 1600s. But it was, you know, to look at, and you can see the basic structure of cells. Okay. It wasn't until about 40 odd years ago that electron microscope came in. It might be as well almost 50. I'm getting old now. Okay. And so you were suddenly able to see what we call subcellular features, like ribosomes, like the pores in the nucleus and things like that. Okay. But seriously, when dear old Mendel in the 1800s was talking about units and particle and to do with genetics, which we'll obviously cover later on, they didn't even know about chromosomes. They couldn't see that level of detail down a microscope to be able to watch mitosis. So it's really, really quite interesting that we've come such a long way, you know, in less than 200 years, really. So we need to think about what an electron microscope is, and this is the key point. So an electron microscope, okay, uses electrons to see things. So they're much smaller than, it can see things much smaller than light microscopes because it's using a much smaller particle. And electrons mean that you can actually see down to atom size in a really powerful electron microscope. We don't do this, but you just need to know that it has a much higher magnification. And this is the, you can blow things up as large as you like, so you can have quite high magnification with light microscopes, but the key thing is, and it has a better resolving power, and that's, it can see the distance between things. It's to do with how close it is. It's all to do with physics, really. You just need to know it has higher resolving power than a light microscope. Okay, that's quite easy, isn't it? And this means that it can be used to study cells in much finer detail than with a light microscope. Okay, and it means that scientists, or biologists in particular, can now see subcellular structures and they get a better understanding of how things work. Okay, as I said, it's about 40-50 years ago they really started using it. So that's microscopy. The next bit is the magnification bit. Oops, I hate remembering this equation, so please, you know, don't worry if you keep forgetting it. If you're doing foundation tier, you might be given it. If you're doing higher tier, they might ask you to know it. Okay, so you've got size of image is divided by, if you do that, real size of object. Okay, now I've been thinking about how to remember it because I always forget it. Okay, I'm putting my divide sign in there. And I think if you think about it as size of I over R or O, so I comes first in the alphabet. And I think that's the way you remember it. So you got first over second. Hopefully that will start clicking in. I'll certainly try and remember it now. It's something that I've always struggled with. So don't worry if you do. It's always times 100, it's times 10, times whatever. Okay. It's not difficult to do. You will be expected to do calculations with it. I will put a question in here somewhere where you actually have to do the calculations and I'll talk you through it. All right.